𝗝𝗁𝗵𝗃𝗲 Bismillahir-Rahmanir-Rahim. This presentation is an introduction to astronomy. Imagine standing at the edge of the cosmos, where the infinite expanse of the universe stretches out in a mesmerizing dance of stars, planets, and galaxies. We embark on a journey across the heavens, not merely to explore the outer reaches of space, but to awaken a deeper sense of awe and gratitude towards Allah. This presentation is an invitation to marvel at the wonders above us, to understand the universe's intricate design, and to see beyond the stars, into the essence of Allah's power and beauty. The outline for this presentation is as follows. First, we look at an overview of the universe, starting off with the Big Bang Theory, then following on with the size of the universe, and then to the mysterious dark matter and dark energy. Then we will look at the components in the universe, the motions of the Earth, the solar system, and going further and further outwards to asteroids, meteors, and comets. Then to Einstein's theory of relativity and why it is so important to us. Then as we venture further out into the cosmos, we'll have a look at nebulae, supernovae, pulsars, and black holes. And essentially, the birth and death of stars. And finally, we finish off with the galaxies and quasars. So why study astronomy? The word heavens is mentioned approximately 76 times in the Quran. For example, here is an ayat from Surah Yunus. قُلْ انظُرُوا مَا فِي السَّمَاوَاتِ وَالْأَرْضِ وَمَا تُغْنِي الْآيَاتُ وَالنُّذُرُ عَنْ قَوْمٍ لَا يُؤْمِنُونَ. Tell them, observe carefully all that is in the heavens and the earth, but no signs and warnings can avail those who are bent on not believing. The vastness and complexity of the universe should install awe of Allah and hence humility in us. The components of the visible universe is firstly matter, and matter is made up of atoms. The atom is the basic building block of all molecules in the universe, including biological organisms. The atom itself is made up of elementary particles, like the proton, neutron, electron. The energy that is propagated through the universe is via the electromagnetic spectrum. This spectrum is the range of all wave energies that we are constantly exposed to. Right from the lowest frequencies of radio waves all the way up to the highest frequencies of gamma rays. We also have forces in the universe, and the largest acting force is gravity. Any two large bodies that contain mass are attracted to each other. Now let's have a look at the overview of the universe. The Big Bang Theory is currently the most widely accepted theory that explains the evolution of the universe. It is a scientific model that explains the timeline of the universe from time greater than zero, not time equal to zero. It does not posit any reason or any argument for the creation of the universe. It is only just a mathematical description of the evolution of the universe. And this started off in 1924 when the astronomer Edward Hubble observes that all galaxies are moving away from each other faster and faster. Subsequent measurements estimate the age of the universe to be approximately 13.7 billion years old. This second line of evidence that came about to substantiate the Big Bang Theory is something called cosmic microwave background radiation. And in the early 1960s, scientists had developed this microwave horn antenna, as a way to bounce signals of rockets and satellites that were sent into space. However, they noticed something very interesting, that no matter in which direction at any point of time of day that they pointed their antenna upwards to, they found a background noise. And this was essentially an accidental discovery of leftover heat radiation from the Big Bang. This is a 9-year microwave sky image showing the uniform temperature distribution of this background radiation, which is at approximately minus 270 degrees Celsius. And the variations in color on this map are only 1/10,000th of a degree Celsius. So there are many references to the Big Bang in the Quran. And here in the Big Bang theory, there are several stages. In time equal to 0, which starts off from here, we then have the inflation stage where the quarks form. And then come the first particles, which are your elementary particles, neutrons, protons, and dark matter forms. That matter then begins to coalesce to form hydrogen and helium. This then gets followed by the first formation of atoms. Later, as the matter becomes larger and larger through coalescing, they then begin to attract each other more and more and form clumps of matter. Finally, gravity, stars, and galaxies form. And then we then have a new stage coming about of anti-gravity, where the universe now starts to expand. And not only does it expand, but that expansion actually accelerates until we come now to the point today where the universe is continually expanding. So let's look at the verses of the Quran that refer to these different stages of the Big Bang. So here is an ayat from Surah Al-Anbiya. Have those who disbelieved not considered that the heavens and the earth were a joined entity? Then we opened them and made from water every living thing. Then will they not believe? So here the Quran references the actual starting point of the Big Bang. Another ayat, then he directed himself to the heaven while it was smoke and said to it and to the earth, come into being, willingly or by compulsion. They said, we have come willingly. This is an ayat from Surah 𝗶𝘃𝗃. And this is referencing when the matter starts coalescing and coming together to start forming planets. Another ayat also in this regard. And we have not created the heavens and earth and that between them except in truth. And indeed the hour is coming. So forgive with gracious forgiveness. This is an ayah from Surah Al-Hijr. And then there are several more ayah which cover multiple stages of the Big Bang. For example, there is an ayah in Surah Al-Araf. Indeed, your Lord is Allah, who created the heavens and earth in 6 eras, and then established himself above the throne. He covers the night with the day, chasing it rapidly, and he created the sun, the moon, and the stars, subjected by his command. Unquestionably, his is the creation and the command. Blessed is Allah, Lord of the worlds. Another ayat from Surah Yunus. Indeed, your Lord is Allah, who created the heavens and the earth in 6 eras, and then established himself above the throne, arranging the matter. There is no intercessor except after his permission. That is Allah, your Lord, so worship him. Then will you not remember? Another ayah from Surah Hud. And it is he who created the heavens and the earth in 6 eras, and his throne had been upon water, that he might test you as to which of you is best indeed. But if you say, indeed, you are resurrected after death, Those who disbelieve will surely say, this is not but obvious magic. And finally, an ayat describing the current state of the universe. And the heaven we constructed with power, and indeed we are expanding it. This is an ayah from Surah Ad-Dariyat. So here we can see that actually the Big Bang theory supports these ayats from the Quran. The size of the universe is truly immense. In terms of time, on the x-axis, it is approximately 13.7 billion years old. However, in terms of size, it is approximately 92 billion light years across. And this is because the rate of expansion of the universe is actually faster than the speed of light. It is estimated that there are about 2 trillion galaxies across the universe, and each galaxy has approximately 100 billion stars on average. And this is something which is truly astonishing, especially when you consider in context as to how tiny our planet Earth is in comparison to the rest of the universe. Another interesting aspect that astronomers have been grappling with for many decades is the concept of dark matter and dark energy. So it was first conjectured that there is dark matter in the universe because there's not enough visible matter within galaxies to hold the galaxies together by gravity. So the mathematical calculations showed that there has to be a lot more invisible matter within galaxies and even between galaxies to be able to hold all this matter together. Then there is dark energy, which is an unobservable energy driving all galaxies further apart from each other at an accelerating pace. So what is the total universe made of? It is estimated that dark matter comprises of approximately 21% of the universe, dark energy approximately 74% of the universe, and the visible matter is only about 5% of the universe. So there is still so much more out there that we do not know. And this should be something that should be very humbling for us. Now let's move on to what are the components inside this universe. Starting off from the motions of the Earth. It was Al-Biruni in approximately 1000 AD who postulated the daily rotation of the Earth. The Earth has got several motions. One motion is called precession, where the Earth actually spins like a top. And this takes approximately 25,700 years for it to do one rotation of this top. The Earth also has an axial tilt change between 22.1 degrees and 24.5 degrees. And so it tilts back and forth between these angles. The Earth also has a revolution around the Sun, which is approximately 365 days. Another curious motion of the Earth is that it bounces like a tennis ball because of the Moon's gravity. So as the Earth goes around the Sun, the Moon is also going around the Earth at the same time. And as the Moon moves around the Earth, it exerts a gravitational pull on the Earth. So the Earth is constantly moving towards the Moon while it is rotating or revolving around the Earth. The solar system, in turn, revolves together with the rest of the Milky Way. and the Milky Way moves through the ever-expanding universe. So the Earth has got several very complex motions, and yet we go about our daily lives completely oblivious to all of these motions. Let's move outwards now into the solar system. So the entire solar system is very finely balanced with exact masses of the planets and distances between them. We have the rocky planets like Mercury, Venus, Earth, and Mars, which are closest to the Sun. Then there is an asteroid belt which separates Mars from Jupiter. Jupiter, Saturn, Uranus, and Neptune are all gaseous planets. And right on the outside of the solar system is what is referred to as the Kuiper belt. So firstly, we must note that our Sun is a yellow dwarf star that is very stable. And planets form when material in the disk around a pre-existing star begins to condense around rock and ice cores. The asteroid and Kuiper belts are the remnants of the formation of the solar system. The asteroid belt has more than 1 million large asteroids and millions more smaller ones. They are made of rock or metal or both, and are significantly affected by the gravity of Mars and Jupiter. There are radar stations on Earth which are constantly monitoring any incoming asteroids, as they may pose a major danger to the planet. When these asteroids are attracted by the Earth's gravity and enter into the Earth's atmosphere and lands on the ground, they are then termed meteorites. They are small pieces of rock which has broken off from asteroids and comets, sometimes even the moon and other planets. They have a very shiny surface because they've been burnt up by the Earth's atmosphere. And so far, there have been about 50,000 meteorites found on Earth. One noticeable aspect about these meteorites is that when they enter into the Earth's atmosphere, they form what is commonly called a shooting star. And twice a year, in late June and late October, we have the torrid meteor shower. And this meteor shower is caused by the debris of ice and dust coming from the comet 𝗃𝗵𝗃𝗃 as it passes through our solar system. It is worth noting here that ancient civilizations lived in mortal fear of being hit by an asteroid or comet. They even had folklore stories of this happening to past civilizations, resulting in massive destruction. These people also had outdoor lives and slept under the stars, so every night they would see shooting stars and sometimes comets. Moreover, they could even see these things sometimes colliding with the moon and the huge explosions it caused. Hence why they lived in mortal fear of a meteorite hitting the Earth. Going outside the solar system, we have comets, and these exist in the Kuiper belt beyond Neptune, but can be pushed into a short orbit around the Sun. The Sun's heat vaporizes these icy formations and leaves behind a dust and iron tail which are hundreds of thousands of kilometers long. They are made up of ice, frozen gases, and organic compounds, and are thought to be the most likely source of water and carbon on Earth. A conundrum that existed for astronomers at the turn of the last century was how to explain the position of certain stars. For example, a certain star would be observed to have a certain position from Earth. However, as the Earth revolved around the Sun, the true position of the star was actually in a completely different location. So they were very perplexed as to how to explain this phenomenon. And it was Albert Einstein who had an incredible epiphany where he postulated that space is curved due to gravity, And the more curvature, the larger the distance that light has to travel, hence the slower time is. And this was called the theory of general relativity. Approximately 10 years later, he had a second epiphany, where he postulated that the faster you travel closer to the speed of light, the slower time moves for you. So you may be here on Earth currently, and you send your better half on a rocket at the speed of light into outer space. When she returns, you would have become an old man, but she would have hardly aged. So why is the theory of relativity, both general and special relativity, important to us? Well, in terms of GPS locations, you have the GPS satellites which are in space, and they then use the equations from general relativity to better triangulate your position on Earth. And due to general relativity, they have to make a 45 microsecond correction. And due to special relativity, they have to make a 7 microsecond correction. So GPS receivers use the time at which each signal from a satellite was emitted, together with the speed of light, to calculate the distance between itself and the satellites it has communicated with. So even though it is still regarded as Einstein's theory of relativity, but in reality it is now fact. It is just like the Big Bang theory. They start off as theories initially, but as time goes on, more and more evidence accumulates supporting the theory to the point where they are now regarded as fact, especially when we use it in our daily life. The word theory is just something that has stuck over time. Now let's look at stars. Nebulae are the nursery for new stars, and they were first noticed by Abd al-Rahman al-Sufi in the year 964 AD. A nebula is an enormous cloud of dust and gas, which are mainly hydrogen and helium, occupying the space between stars in a galaxy. Gravity pulls together these clumps of dust and gas. And as these clumps get bigger and bigger, their gravity gets stronger and stronger. Finally, the clumps of dust and gas get so big that it collapses from its own gravity. The collapse causes the material at the center of the cloud to heat up, and this hot core is the beginning of a star. Stars are kept in balance by the inward force of gravity, squeezing it together, and the outward force of heat from its nuclear fuel going outward. When the nuclear fuel is consumed, if the star is greater than 8 times the mass of our Sun, it can collapse in as little as 15 seconds, and this creates an extremely bright, super powerful explosion called a supernova. This is an image of the supernova which occurred billions of years ago, but was seen on Earth in 1987. And these supernovae leave behind a dense core, which is usually a neutron star, and a cloud of hot gas, which has been blown outward. And this hot gas forms another nebula. Pulsars are neutron stars that are about the size of a large city but contain more mass than the Sun. When a massive star runs out of fuel, it collapses in on itself and explodes into a cloud of dust, forming a nebula. The core nugget of material left over is what is called a neutron star. Typically, they are only about 20 kilometers in diameter. but can contain twice the mass of the Sun. They rotate very fast, sometimes hundreds of times per second, and emit strong beams of radiation outwards very rapidly. Their gravity is so strong that they can even suck in matter from neighboring stars. After a supernova, if the remaining dense core is more than 3 times the mass of the Sun, then a black hole is formed. This results in a gravitational field which is so strong that not even light can escape it. Hence, they are invisible. Every large galaxy has a supermassive black hole at the center. And they are detected by observing how nearby stars and nebulae interact with them. These are maybe some of the most mysterious phenomena in the universe, because what goes on inside a black hole is still unknown. Because inside a black hole, all the known laws of physics breaks down, including all the elementary particles that make up the universe. Galaxies range from 1 million stars to a few 100 billion stars. All galaxies rotate, and their rotation enables star formation. There are many different types of galaxies. Galaxies are continuously being formed and destroyed. Most typically, we find spiral galaxies. And when two galaxies collide with each other, that is when they give rise to other shapes, such as the irregular, elliptical, and peculiar lenticular shaped galaxies. Quasars have been only discovered fairly recently. These are young galaxies near the edge of the universe. This is where thousands of stars collide to form a supermassive black hole, with a mass ranging from millions to tens of billions of solar masses. And they are surrounded by a gaseous accretion disk. Because their gravity is so strong, they pull in all the surrounding matter to form this accretion disk. And they can be up to 1,000 times brighter than the Milky Way, giving off very strong ultraviolet rays. In conclusion, the Big Bang Theory shows the vastness of the universe from virtually nothing. Imagine how much more Allah can create so easily. This brings to mind the hadith on how huge Jannat would be, and more alarmingly and equally how huge Jahannam would be. The precise order and complexity of the cosmos, from the orbits of the planets and galaxies to the balance of forces, all illustrate Allah's unmatched wisdom and power. And this vast universe invites us to ponder our place within Allah's grand design. And this is really so valuable for muraqabah, or contemplation. There are 2 very good articles on the BBC news website. First one is entitled The Benefits of Deep Time Thinking, and the link is posted here. And essentially it says, when one reflects on how short one's own lifespan is within the billion years chronologies of the Earth, it can feel pretty daunting. From the planet's perspective, our lives are momentary flashes of light on the surface of a lake, briefly bright but quickly gone. Thinking about deep time can therefore be a sublime experience, astonishing but tinged with the awareness of one's own mortality. Another article is The Upsides of Feeling Small. Encountering things which are far bigger than yourself can provoke a mixture of emotions: astonishment, wonder, awe, but also humility. Back in the 18th century, writers and intellectuals sought to define this composition of feelings as the word sublime. Through the sublime, they found a deeper sense of meaning about their place within the world, as well as an awareness of the powers and limits of their own intellects. As the essayist Joseph Addison wrote in 1712, our imagination loves to be filled with an object, or to grasp at anything that is too big for its capacity. We are flung into a pleasing astonishment at such unbounded views, and feel a delightful stillness and amazement in the soul at the apprehension of them. One thing that made the sublime so appealing to William Wordsworth, who was an 18th century poet, and others, was how it stretched the imagination. There is a lot of recent research on the emotion of awe. And the takeaways from this is that awe creates positive experiences, and in so doing, it creates resilience. There's also awe from negative experiences, which helps bring together people, especially in times of crisis. And lastly, awe also makes you forget your own existence temporarily. So by thinking about the universe, by contemplating on it, we begin to see ourselves in perspective, both in time as well as in space. And this contemplation then leads us to the names of Allah. One name that comes to mind is Al-Malik, the sovereign. And the description is, Allah is the owner and ruler of the entire universe, visible and invisible, and of all creation from before the beginning and after the end. Another name is Al-Kabir, or most great or infinite. Allah is the greatest, whose greatness stretches from before the beginning until after the end. There is no differences for him between the creation of an atom and the infinite seeming universe. This is his grandeur, as much as we can understand it. He is greater than that. Jazakallahu khairan. Assalamu alaikum wa rahmatullahi wa barakatuhu.